For years, the automotive industry has been chasing a near-mythical promise: an electric car capable of traveling 1,000 miles on a single charge. It's been talked about in interviews, conferences, and even on social media by famous CEOs. But as much as technology has advanced, this milestone has always seemed to slip through the engineering fingers. Until now, CATL, the world's largest battery maker and a longtime partner of Tesla, appears to have crossed that threshold with something few expected to see so soon: a lithium-metal battery with more than 500 dodeuerge per kilogram. That number alone would be enough to raise eyebrows in any laboratory in the world. The impact of this discovery goes beyond technical charts and spec sheets. We're talking about an energy density that simply blows away Tesla's own 4680 batteries, which deliver 272 watt-hours, and even the most advanced solid-state batteries, which don't exceed 375 watt-hours. In other words, it's as if the electric car's tank has tripled in size without increasing a single gram. And if before the physical limit of autonomy was a barrier, now it seems more like a matter of time. Or rather, of mass production. The most impressive thing about all this is that this innovation didn't happen by chance. CATL is already known for turning bold ideas into tangible products. They are responsible for supplying more than 70% of the batteries that power Tesla cars in China and other parts of the world. So when they announce something of this caliber, the market stops. Because historically, when they talk about it, it's because they've already tested it. And when they test it, it's because they're about to manufacture it. Apparently, the secret lies in an almost surgical re-engineering of the cell's chemical structure. By using metallic lithium as the main anode material, CATL has created a cell that stores energy in a much more efficient and compact way. This not only increases the vehicle's range, but also reduces the space and weight needed to store energy. A smaller, lighter car with more power and a smaller battery? It sounds like the stuff of science fiction, but it's becoming a reality before our eyes. And when you talk about 1,000 miles of range, you're no longer dealing with an incremental improvement. This is a paradigm shift. It's the kind of innovation that makes old discussions about range, charging anxiety, and even charging infrastructure obsolete. Because let's face it, if you can go 1,000 miles on a single charge, charging stops being a hassle and becomes just an occasional convenience. That's the game changer that CATL is bringing to the table. And the most curious thing is that, despite the excitement, the development of this lithium-metal battery did not happen overnight. CATL has been investing heavily in this type of technology for over a decade. They have been quietly accumulating research, data, and advances until they were able to present a functional prototype with superior performance to anything else on the market. And, if the company follows the typical pace, this technology should leave the labs and hit the streets in the next 2 years. What really makes this new battery so innovative is in the tiny details, invisible to the naked eye, but huge in impact. CATL's big move was to replace the traditional graphite anode with pure metallic lithium. It may seem like just a material swap, but it changes everything. Metallic lithium has a theoretical storage capacity about 10 times greater than graphite. In other words, you can store an absurd amount of energy in a much smaller space, with much less weight. It's like swapping a styrofoam box for a titanium safe of the same size, only now full of energy, ready to explode in performance. And when it comes to performance, the impact is immediate. A car like the Tesla Model Y, which currently delivers about 330 miles with a 75 kilowatt battery, could easily jump to over 600 miles with the same capacity just by changing the cell type, without increasing the battery, without changing the structure of the car. This completely changes the way engineers design electric vehicles. It stops being a competition for space and weight and becomes a race for efficiency and intelligence. Now imagine what a 95 kilowatt battery with this technology would be capable of doing. The 1,000-mile mark ceases to be theoretical and becomes a tangible, real goal. And the most interesting thing is that, with this autonomy, it is not only everyday cars that benefit. The same technology can be applied to long-distance trucks, urban transport vans, electric buses, and even small electric planes. We are talking about a leap that spans entire industries. That's where something comes in that not everyone considers, but that makes all the difference: the emotional impact of autonomy. Knowing that an electric car can travel 1,000 miles without recharging changes the driver's mental state. It puts an end to that range anxiety. It takes away the fear of being stuck on the road, and that, in itself, is worth millions in perceived value. Innovation isn't just in the number, but in what that number does to people's trust. Another little discussed, but highly relevant advantage is that the increase in energy density allows for smaller batteries. With less space taken up in the car, there is more room for passengers, luggage, and auxiliary systems. And this opens the door to bolder, more aerodynamic designs, or even more compact vehicles with the performance of giants. The future doesn't need to be bulky to be powerful, and the technical secret behind this revolution is not limited to the anode. The internal structure of the cell has been completely rethought. CATL optimized everything from the coating to the behavior of the ions during charging. The goal was simple: extract as much energy as possible without compromising the stability of the cell. The result is a battery that not only delivers more, but delivers it more safely and consistently. The biggest issue still holding lithium-ion batteries back from dominating the streets is durability. There's no point in having a powerful, compact, and super light battery if it can't withstand hundreds or thousands of charge and discharge cycles. And that's where the Achilles heel comes in. CATL's first prototypes reached about 483 cycles before they started to lose performance. For those who understand batteries, that's not much. A good traditional lithium-ion pack can easily go through 1,000 cycles. But that doesn't mean the game is lost. Far from it. The CATL team itself knows that this number needs to go up, and fast. That's why they've started investing heavily in new ways to understand how the battery wears out from the inside. No guesswork. They've created ultra-detailed analysis methods that track, almost like a blood test, the behavior of the battery's components throughout its life cycle. It's like opening a laboratory inside each cell. With this, they're able to see exactly where the problem lies and how to fix it. The biggest culprit detected so far is the electrolyte. This liquid, or gel, that allows ions to move between the anode and the cathode wears out as the battery is used. In the specific case of lithium-metal batteries, around 71% of one of the main salts present in the electrolyte degrades before the battery stops working. This number attracted attention and served as the starting point for an important change: developing a new electrolyte formula that is lighter, more stable, has better ionic conductivity, and takes up less space in the cell. The change didn't take long to show results. The new formula, combined with a reconfiguration of the cell's interior, has already doubled the useful life of the prototype in the laboratory. And that was just the beginning. CATL began using artificial intelligence to analyze millions of chemical combinations and predict which formulas would perform best before they were even physically tested. This accelerates battery development by years and allows advances to be made in record time, something that would have been impossible just a decade ago. Of course, there's still a long way to go. CATL engineers are the first to acknowledge that reaching nearly 1,000 cycles without significant loss of performance is still a challenging target. But with the new pace of innovation, combining materials science, real-time data analysis, and AI optimization, that hurdle may soon be falling. And when that happens, we can truly say that we're looking at the ultimate battery. It is worth remembering that durability is not just a technical issue, but also an economic one. The more cycles a battery can handle, the lower the cost per kilometer driven. and the lower the environmental impact, since fewer units will need to be replaced over the life of the car. So, solving the problem of durability is not a bonus. It is a central piece in the puzzle of mass electric mobility. It's no coincidence that Tesla has maintained such a close relationship with CATL. Elon Musk's company has always been known for being 2 steps ahead when it comes to innovation. And now, with this new lithium-metal battery about to hit the scene, this partnership could yield results that no other automaker will be able to match for a long time. After all, while other manufacturers are still trying to master the basics of solid state, Tesla could already be lining up production of vehicles with a 1,000-mile range. This changes everything, from the design of the models to the way consumers view an electric car. The compatibility between CATL's technologies and Tesla's vehicle architecture is not just a happy coincidence. It is the result of years of strategic alignment. CATL provides cells, but also data, technical support, and ongoing advancements. Tesla, in turn, is integrating these innovations with astonishing speed. It is not a stretch to imagine that within 2 to 3 years, the first Tesla with a lithium-metal battery will be on the road. And when that happens, it will not only be a technological leap forward, it will be a new era in the automotive industry. Imagine the impact this will have on models like the new generation Roadster, a supercar with a 1,000-mile range, incredible acceleration, and reduced weight due to its higher energy density. We're talking about a car that not only delivers incredible performance, but also redefines what we understand as the limits of an electric vehicle. And that's not to mention the Tesla semi-trucks, which can benefit even more from this extended range, especially on long routes and high-demand logistics. But Tesla's plan goes beyond power. The real advantage lies in democratizing this technology. A lighter, smaller, and more capable battery also means lower production costs per kilometer of range. This means Tesla can apply this type of cell to entry-level models, such as the long-awaited Tesla Model 2, which promises to hit the market with a price tag below $25,000. The equation is clear: more range, less battery, lower cost. A combination that could simply crush the competition. And while rivals are still debating how to achieve 400 or 500 miles of range with their current batteries, Tesla is aiming for twice as much, and with greater efficiency. The transition to these new batteries should also make the cars even faster to charge, and less reliant on supercharged charging stations. This will also benefit regions with limited infrastructure, expanding Tesla's geographic reach in emerging markets. There is also an invisible but very important gain: image. A car with 1,000 miles of range becomes a headline, a meme, a bar conversation, and goes viral on social media. And Tesla has always known how to use this like no one else. Launching the first production model with this milestone is more than a technical feat. It is a masterstroke on the global marketing board. This attracts investors, knocks down the competition's shares, and further increases the cult following around the brand. While the spotlight is on lithium metal, CATL is once again surprising us by pulling out another ace up its sleeve: sodium batteries. And not just any battery, it's the revolutionary Naxtra, a cell that looks like it came straight out of a science fiction project. With an energy density of 175 W/Cr, over 10,000 charge cycles, and the ability to charge 500 kilometers in just 5 minutes, Naxtra not only defies the limits of physics, but also redefines what cost-effectiveness means in the world of electric vehicles. And the most intriguing thing? This battery is based on an incredibly abundant element: sodium. For those unfamiliar, sodium is the common salt that is found even in seawater. Unlike lithium, which must be extracted from remote and scarce locations such as salt flats and mines controlled by a few countries, sodium is everywhere, and that changes the whole equation. CATL saw this as an opportunity to create a more affordable battery without sacrificing performance. The result is a technology that has the potential to power millions of popular cars around the world, including Tesla's cheaper electric cars in the future. And there's more. These sodium batteries are not only cheap and easy to produce, they are incredibly fast to charge, even outperforming lithium batteries in some metrics. Just to give you an idea, a 5-minute charge gives you over 300 miles of range. That's roughly the same amount of time it takes to fill up a gasoline-powered car. And we're not talking about a distant promise. CATL has already started production of these batteries for heavy-duty commercial vehicles, with larger versions coming to market in the coming months. Another point that draws attention to Naxtra is its durability. 10,000 charge cycles is an almost surreal number, especially when we remember that most current lithium batteries start to lose performance after 1,000 or 2,000 cycles. This means that, with a sodium battery, you can drive for decades without worrying about replacing it or losing autonomy. A true change in the concept of maintenance for electric cars. And that's not all. The chemical characteristics of sodium give these batteries impressive thermal resistance. They operate in extreme temperatures, from 40 degrees to over 70 degrees, without suffering significant degradation. This makes them the perfect choice for countries with harsh winters or scorching summers. And anyone who has ever faced an electrical failure in the cold knows how much of a problem this can be. With Naxtra, this type of concern becomes a thing of the past. From a strategic point of view, CATL made a smart move. While the whole world was chasing lithium as if it were white gold, it bet on a more abundant, cheaper, and safer alternative. And now that the first results have started to appear, the entire industry is looking at sodium batteries with different eyes. Not as a plan B, but as a real, viable, and, who would have thought, competitive solution. If there's one thing that scares any electric car owner, it's the idea of being left stranded in extreme cold or scorching heat. A battery that freezes, explodes, loses its range. These are the nightmares of those who live in regions with harsh climates. But CATL seems to have looked directly at these fears and created a suitable response with the Naxtra battery. What's impressive is that this battery remains strong and steady even when the temperature drops to 40 degrees Celsius. That's no exaggeration. Tests have shown that it retains up to 90% of its usable capacity even in freezing temperatures, something that not even the best lithium batteries can do. And if the cold isn't a problem, neither will the heat. The Naxtra has been tested at temperatures above 70 degrees and has continued to perform normally. This is a relief not only for those who live in places with sweltering summers, but also for transport fleets, school buses, and industrial vehicles that have no choice but to operate all day long, under any conditions. The thermal resistance of this battery redefines what is possible when it comes to performance in hostile environments. And honestly, it seems like it was made for just that, to take a beating. One reason for this thermal resilience is sodium's more stable chemistry compared to lithium. While lithium can ignite when shorted or overheated, sodium tends to remain stable even when punctured or damaged. CATL ran tests where they cut the Naxtra cell in half, and nothing. No smoke, no spark, no explosion. This completely changes the perception of EV safety, especially for those who still associate electric batteries with fires in tunnels or parking lots. Another detail that makes all the difference is the low flammability of the internal structure. Since sodium has a less reactive chemical structure, it drastically reduces the risk of serious thermal failures. In other words, in the event of an accident, collision, or even sabotage, the chance of an explosion is practically zero. For those who drive with children in the back seat or transport sensitive cargo, this is a huge burden. And it's not just talk. There are already videos and technical reports proving the resistance of these prototypes to extreme tests. And it gets even better. Even when the battery is at a state of charge that is almost zero, like 5%, it can still be charged quickly, even in sub-zero temperatures. This is unreal. With 15 minutes of charging, It goes from 5% to 80% at 10 degrees Celsius. In other words, even in the middle of a snowstorm, you can recharge and continue your journey without any problems. This eliminates once and for all the famous winter anxiety that so affects EV drivers in countries in the Northern Hemisphere. When it comes to cost-effectiveness, CATL's sodium batteries come into the field with an almost unfair advantage. Starting with the fact that sodium is one of the most abundant elements on the planet. It is present in table salt, seawater, soil, practically everywhere. This means that, unlike lithium, which requires intensive mining and expensive export routes, sodium can be extracted easily and at a reduced cost. And this is directly reflected in the final price of the battery. CATL estimates that, with large-scale production, these new cells could be up to 30% cheaper than LFP cells, which are already considered the most affordable on the current market. This fact alone would be enough to turn the tables. But there is more. The low cost does not come only from the raw material. The structure of sodium batteries allows the use of aluminum in the anode current collector, replacing copper, another expensive material subject to instability in the global market. In addition, the cathodes of these batteries can dispense with metals such as cobalt and nickel, further reducing the costs and also the socio-environmental impacts associated with mining these resources. This savings combo could be the game-changer that was needed to finally make electric vehicles as affordable as combustion-powered ones. Tesla, for example, which is already targeting an entry-level model in the $25,000 range, could take advantage of this new generation of batteries to cut costs even further. And it's not just about reducing the price of the battery itself, but also about streamlining the entire production chain: logistics, storage, transportation, assembly. Lighter and cheaper batteries affect every link from the factory to the end consumer. And the gains don't stop at value. Cheaper batteries also mean less risk for smaller automakers and startups. With Naxtra, emerging companies will be able to enter the EV market with much more confidence, knowing that they have access to a powerful, safe, and financially viable technology. This democratizes production and takes away the monopoly of the big companies. The revolution doesn't just come from the top down, it comes from all sides. Now, think about scale. If the price per kW drops below $100, as the IDTechX report predicts, the total cost of producing an EV could plummet. This would create a domino effect in the market. Increased supply, lower consumer prices, greater mass adoption, and, of course, a much more positive environmental impact as electric cars go from being a luxury for the few to becoming the global standard.